In this video, we present our paper SAMWISE, Infusing Wisdom in SAM2 for Text-Driven Video Segmentation. Referring video object segmentation relies on natural language expressions to segment an object in a video. However, existing methods face key limitations. Some operate on short independent clips, which restricts their ability to reason over long-term context. Others process the entire video offline, making them unsuitable for streaming applications. In this work, we designed a method that operates in a streaming-like fashion while still leveraging past context. Our key insight is that Segment Anything 2 already introduces a memory bank that retains information from previous frames, allowing context-aware streaming segmentation. This brings us to the central question. Can we transfer the segmentation and tracking capabilities of SAM2 to perform streaming referring video object segmentation? At first, this seems like a natural next step, but instead, this raises several non-trivial challenges. First, text understanding. SAM2 was designed for geometric prompts like points or boxes, and has no native support for semantic prompts like language. Second, temporal modeling. For RVOS, it's not enough to match visual appearance. We also need to recognize the object based on how it acts over time. This means reasoning over its temporal evolution, but SAM2 processes frames independently. Third, we identify a novel issue we call tracking bias. When the referred object is temporally occluded, ambiguous, or not yet visible, SAM2 might start tracking an incorrect object that loosely matches the text. Without human correction, that error persists in the following frames. In this work, we make SAM2 wiser to overcome these challenges. We keep it with three new capabilities: text understanding, temporal modeling, and the ability to correct tracking mistakes, all without any fine-tuning and without relying on external large visual language models. This is the architecture of SAMWISE. It builds entirely on top of the frozen SAM2 and a frozen text encoder. We introduce only a few lightweight dedicated modules, ensuring minimal overhead. To enable text understanding, we start by selecting the contextual token from the text encoder. This token captures high-level semantic cues about the referred object. We extend SAM2 prompt encoder with a learnable projection that maps this token into the prompt space. This lets the textual expression directly guide the segmentation. Then, to unify text and visual modalities, we design a cross-modal temporal adapter. This adapter is inserted at multiple intermediate layers of both the visual and textual encoders, and it enables deep interaction between modalities in a residual fashion. The adapter performs cross-attention in both directions, letting each modality progressively enrich the other. In SAMWISE, we model motion evolution directly within the feature extraction stage inside the cross-modal temporal adapter. The key observation is that object motion typically spans a localized region of the image. So, instead of attending globally, we perform self-attention across spatially and temporally nearby regions. This lets us to effectively capture motion cues while significantly reducing unnecessary computation. Finally, we address the tracking bias, the phenomenon where SAM2 continues following the wrong object even when a more relevant one appears. To detect this, we compute a memoryless token derived from a cross-attention between the current frame features and the prompt. This token captures what the referred object should look like now, without being influenced by past predictions. We compare it with SAM2 current mask token. If the two differ, our conditional memory encoder fuses the two predictions together. The resulting mask is then stored in the memory bank, allowing SAM2 to balance historical context with unbiased information from the current frame. Now, let's look at a practical example that highlights the challenges of streaming processing. Here, we have a sequence of frames and a textual query, the guy who is drinking. SAMWISE begins segmenting in a streaming fashion frame by frame. At the start, no one is clearly drinking, but one person holds a glass more visibly. So, SAMWISE segments him. Then, the second person actually starts drinking. SAMWISE detects this and switches to the correct object. As the action unfolds, it tracks this person across frames and persists through occlusions. Thanks to the memory bank, the model correctly re-identifies the target after the occlusion ends. Numerically, we see that each of our modules progressively enhances SAM2 for the task of referring video object segmentation. Starting from just the projection into the prompt encoder, we already enabled the task with 45.2% of accuracy. Adding our cross-modal adapter and conditional memory encoder brings us to a final 55.5%, a significant improvement showing the contribution of each part. SAMWISE sets a new state-of-the-art across multiple referring video object segmentation benchmarks, outperforming even methods that rely on large visual language models with billions of parameters. In addition, it achieves state-of-the-art results also at image level on referring image segmentation benchmarks. Finally, our model remains highly efficient. We add and train less than 5 million parameters, bringing the total to just 202 million and making SAMWISE the smallest model in its category.